Precalculus chapter 4.2, exercises 41 through 54, solve trigonometric equations for theta and find unknown sides of right triangles. So let's look at this problem set 41 to 48. Find the acute angle theta that satisfies the given equation. Give theta in both degrees and radians. You should do these problems without a calculator. So for an acute angle, what is an acute angle? For an acute angle, you're going to have a theta that's going to be greater than 0 degrees and less than 90 degrees. And so to do problems without a calculator, if we look to our unit circle, we are talking about these angles right here. And in blue, we have these angles in degrees, and in red and radians. So 30 degrees is equivalent to pi over 6 radians. 45 degrees is equivalent to pi over 4 radians, and 60 degrees is equivalent to pi over 3 radians. So and where do we get information on how to deal with that? If we look at our ACP formula chart, special right triangles, that's what we're talking about. If we have a 30, 60, 90 right triangle, meaning if we have like this angle here, let's say this one is 30 degrees. Okay, and then this one here would be 60 degrees. Then we have x, and x is our smallest side. X square root of 3 is our next smallest side. And then we have our hypotenuse is 2x. And then if we just orient the same triangle a little differently, like this, we have our theta here at 60 degrees. Well, in this instance, our x is going to be down here, x squared root of 3, and 2x again is our hypotenuse. So those are a couple of our possibilities. And this last one, this 45, 45, 90 right triangle, is where we have, sometimes you call it isosceles right triangle. So you have a triangle that looks like this. Here's a 45 degree angle here. And obviously this one up here is 45 degrees. Then your short sides are x and x. And your hypotenuse is going to be x squared root of 2. So these triangles are the ones that we're going to use to perform our analysis here of what's going on. Okay, back to our exercises. Sine theta equals 1/2. Well, what we're looking at is sine theta is going to be equal to our opposite over our hypotenuse. So we're looking for a triangle where the ratio between our opposite and our hypotenuse is 1/2. So going back to our special right triangles we just sketched here, where do we see that type of ratio? Where do we see a 1/2? Well, here we have it, this x over 2x. So we will say sine 30 degrees equals our opposite side over our hypotenuse, which is 2x, which cancels to be 1/2. So therefore, if we take the inverse sine of sine 30 degrees, we're going to have so 30 degrees. I'm kind of telegraphing, aren't I? Inverse sine of sine theta is going to be equal to inverse sine of 1/2. And inverse sine of sine will cancel. We have theta equals the inverse sine of 1/2. What angle is going to give us the sine of 1/2? Well, it's going to be this one where we have our, oops, this is what I want. It's going to be this one where we have our opposite over hypotenuse equal to 1/2. So we say theta equals 30 degrees, and also in radians, theta is equal to pi over 6. And those are angle measures in degrees and radians respectively. Next, now we'll go to the odd numbered problem, again 43. Cotangent theta equals 1 over square root of 3. Well, cotangent theta is equal to the reciprocal of tangent theta. So therefore, we would know that for this same angle, the tangent of theta is going to be square root of 3. So let's go look at our special right triangles. Where do we see square root of 3 in evidence? Well, we see it down here and also here. So it's going to be a 30-degree angle or 60-degree angle, either one. How do we get square root of 3? If we take the ratio, if we take tangent of 60 degrees, that's going to be opposite over adjacent. So we would say cotangent, change the tangent of question mark angle equals x square root of 3 over x. Where do we see that? Well, it's going to be the tangent of 60 degrees equals square root of 3. Therefore, we conclude that theta is going to be equal to 60 degrees. And in radian measure, theta is going to be equal to pi over 3 radians. Now, usually it's conventional that you don't need to put, if you have, in terms of pi, the radian description there, units, but there we have it. Okay, next, another problem, 45, secant theta equals 2. Well, what is secant theta? We'll go to our ACP formula chart here. Secant theta is equal to 1 over cosine theta. Or the reciprocal of cosine theta. And so what we're looking at is, what we're looking for is an angle where the cosine is adjacent over hypotenuse. So where do we see, it looks like we have cosine of 60 degrees equals x over 2x. So I'm going to write this down. And that's going to be equal to 1/2. Well, secant is going to be a reciprocal over cosine, so our secant of theta is going to be 2 over 1, which equals 2. Therefore, the secant of 60 degrees is equal to 2. Therefore, we say theta is equal to 60 degrees. And we also say that theta, in terms of radians, is equal to pi over 3 radians. Next on the problem, 47. Find the acute angle theta that satisfies. Okay, we have tangent theta equals square root of 3 over 3. Well, it's going to be either one of these things here, most likely. Tangent theta equals square root of 3 over 3. So let's go and look at these triangles. Where do we see square root of 3 over 3? Well, that's square root of 3 over 1 for tangent. How about if we have x over square root of 3? So let's try 30 degrees. So we're kind of just looking at it and figuring out what it is. So we say tangent 30 degrees is equal to, again, looking at the thing, we have x over x squared root of 3. So that cancels out, so we have 1 over square root of 3. So let's go ahead and try to eliminate this radical in the denominator by multiplying by the fraction square root of 3 over 3. What's going to happen in the numerator, we're going to have 1 times square root of 3, which is going to be square root of 3, and in the denominator, we have square root of 3 times square root of 3, or 3. So since the tangent of 30 degrees equals square root of 3 over 3, we can conclude that theta is equal to 30 degrees. And in radians, theta is going to be equal to 5 or 6 radians. Now, in these even numbered exercises, we didn't see any 45-degree angles, but let's look here. Cotangent theta, 46. To get 1 over 1, the only place we see 1 over 1 is this x over x. So we could say that cotangent 45 degrees is going to be equal to x, our adjacent, over our opposite, which is x, which equals 1. So therefore, theta is equal to 45 degrees. So that's an example of a isosceles right triangle. Okay, let's go to this next set, which involves this thing here. So I want to erase this so I can thoroughly explain what it is. Okay, what we have is this triangle here. We got a right triangle, and we take where the angle 34 degrees is and draw an arrow, and the side opposite that 34 degree angle is 15, and our hypotenuse is x. So the ratio involving opposite and hypotenuse are going to be sine, in this case of 34 degrees, is going to be equal to our opposite, which is 15, over hypotenuse, which is x. And then to solve for x, we can cross multiply the x. So if we cross multiply the x, we get x sine 34 degrees is equal to 15. And then to isolate, we will divide by 34 degrees, our plot by sine 34 degrees. And so we have x is equal to 15 over sine 34 degrees. And then we can go to our calculator. So x equals 15 divided by sine 34 degrees. Now, my calculator is in radians mode. I keep it there deliberately, have my students consciously consider what's going on. So since we're in radians, I have to put that degree symbol, which I got by pressing this pi key and getting it here like this. And now if we press enter, we're going to get our unknown side, which to the nearest hundredth, x is going to be equal to 26.82. Another way to do this problem is our reciprocal ratio of sine is cosecant. So we could take our cosecant of 34 degrees and set it equal to x over 15. And then we'd have x equals 15 cosecant 34 degrees. And then you put that in the calculator, which ends up being 15 over sine 34 degrees, same thing. On a Theta Inspire calculator, we have the fortune of having, in addition to sine, cosine, tangent, also cosecant, secant, and cotangent, just for your information. I'm going to try to keep things in terms of sine, cosine, and tangent, just for more universality in its application here. For those of you who might have a TI-84 or some other calculator that doesn't have cosecant, secant, cotangent. Over here, we have an angle 57 degrees, and we're going to go to our opposite side here, which is 32, and then we're going to have our, this will be, y is going to be our adjacent side. And which ratio involves adjacent and opposite? Well, that's going to be tangent or cotangent. So the tangent of 57 degrees is going to be equal to 32 over y. And cross multiplying this y, we're going to get tangent 57 degrees times y is equal to 32. And dividing by tangent of 57 degrees, okay, those would cancel. We do the same thing on the right side. We're going to have y is equal to 32 over the tangent of 57 degrees. And now to the calculator, we have 32 over tangent 57 degrees. And again, I need to use my degree symbol because we are in radians here. And so for that, to the hundredths place, 20.78. So say y equals 20.78 to the nearest hundredths place. Okay. All right, we're going to do one more, the last algebra problem. We have this inverted triangle here. We have our angle 35 degrees, so I'm going to go over here to the opposite side and find 6. And then down here, our longest side, our diagonal, is always going to be our hypotenuse. And which ratios involve opposite and hypotenuse? Well, sine theta equals opposite over hypotenuse, and cosecant theta equals hypotenuse over opposite. So let's go ahead and do the sine of this thing. So sine of 35 degrees is equal to our opposite side, which is 6, over hypotenuse, which is y. Cross multiplying the y, we get y times sine of 35 degrees is equal to 6. Now to solve for y, if we divide both sides of the equation by sine 35 degrees, we have y isolated on the left side. So y is equal to 6 over the sine of 35 degrees. And so y is going to be equal to, we will get to our calculator, 6 over sine of 35 degrees. Make sure to put in our degree symbol, and 10.46 to the nearest hundredths place. Well, that, my friends, is all the odd number problems, including the even number problem 46. I hope this video lesson has been helpful to you. As always, good luck, and thanks for viewing.